Hello and welcome back to another session of Hacks. It's Byron speaking, and we're looking at tetris-piston. Hacks in the sense of, the hack and not like hexadecimal numbers, now that I hear myself speaking. It feels like I have to clarify that. Even though later there will obviously be a logo on top, so I probably don't have to clarify that. So in one of the previous sessions, I think in Luxies 2, we took a look at tetris-piston and made a few changes in the process, which indeed reduces the performance requirements for that particular program. However, there were a few issues with that. So also I increased the updates per second value as it introduced. Oh no, wait, actually here it starts. So updates per second was required here to have enough updates to actually allow skilled players to play at higher levels. I didn't, I kind of thought about that possibility, to be honest, but I didn't actually think that more than 30 frames will be needed to make this to make this possible. But anyway, and that's quite interesting. It's not surprising to me anymore, and this value here is also nonsense in a way, because it means kind of one additional sample per pixel. Usually you would go in steps of 4, I think. So 4, 8, usually 16 gives you the quality that you actually want, and 0 is no oversampling. And usually, the thing is that I was confused by this name, because samples means, if you have 0 samples, then the pixel wouldn't be visible, right? So that's how that should be, but this is kind of oversamples. That's what it really wants to say. So it's a bit, to my mind, is a bit of a misnomer, but anyway. And considering the blocky graphics and the grid-aligned drawing that happens here, I think, you don't need oversamples at all. Maybe I want to pull this. Bring it in, fast forward, good. What else? Yeah, samples also is quite hardware dependent. So on Windows this may work, but I think only until 8 times oversampling, and on Ubuntu it doesn't seem to be working at all. So whatever that means, so it's not safe to use that. I kind of learned that the hard way now, because 2 projects had problems with that. So now to the interesting part, because we don't only want to talk about stuff, we also want to hack stuff. So one more thing, this is not related to your changes. As you noted on in the YouTube video, the code to draw the tetronymo is somewhat duplicated from when you draw the rest of the game board. I'd like to make the general purpose function that could be invoked, but I couldn't figure out what the parameter types for GL and C would be. So the cool thing is that even though I believe to know nearly nothing about Rust, when I look at other people's code, I always think, damn it, how can they possibly write that? I know this because I have the problems as well, or had the problems, and I think there are various solutions to this that we want to explore in this video. So, where am I? Maybe I go to some other game, catch it just for the fun of it, and then we have a look at the source code here. I think that will be in main, because main does the drawing. So let's see, is there some render? Yes, here we go. Okay, so what is these values here? So one way of doing it, and that's the standard way, is this one. Maybe like this, so we get both values. So this means what? This basically, I thought about this. This looks like unit, but I think in fact it's an empty tuple. This is destructuring syntax. And this means, in fact, a unit is an empty tuple. So usually I think you would put A and B here or something. But if you do this, it's just an empty tuple. So this is basically no value, right? This is unit, but this is kind of valid because of the fact that after let you in fact have the destructuring syntax. So this basically creates a new tuple that has 2 fields. One of them is C, the other one is GL. And as the types definitely do not match here, this sets the type you will see that the compiler will complain when we try to build this, and it will complain in a manner that allows us. Did I not save? I did not save. It will compile or it will complain in a manner that allows us to see exactly what types we have. So this is a graphics context, and this is an OpenGL graphics backend GL graphics. So that's the types there. Another way to do this, I think, would be to specify some nonsense types here. So I say, well, this must be unit and this must be unit as well. I guess now it will tell me similar things, but it might be a bit more difficult to read. And it totally is more difficult to read because we have here a closure, and that kind of is, now tells you, well, this is supposed to be a closure that takes 2 units, but we were fed with these types. So here the types are again. And I wonder, in expansion of for loop expansion, I wonder why this is an expansion. Looks like a macro expansion, even though I don't see a macro here. So that's a bit odd, but that's far more difficult to read here, isn't it? No fun. So probably you would do it the way I did it before. And now the question, how would that be deduplicated? So this is so the context is owned, it seems, and the GL graphics is a mutable borrow to it. So yeah, let's see. Actually, where last time I noticed that the drawing code is somewhat duplicated. So here we draw the next shape and the current. Where do we draw the current shape? So here you draw all the cells. That's fine. So all the blocks that have already been placed in the field. But I actually don't see where the current one is done. I also don't know whether. Yeah, let's see, because I would like to explore ways to deduplicate that. Just real quick, basically. So where's your notion of the current field? Tetris. Here we have a grid, a shape. So the shape is queried somewhere in order to draw it. And I guess you can obtain the shape somehow, right? New shape. Move shape. Come on, return the shape somewhere. Clear shape. Shape to grid. Okay. Maybe shape to grid is used all of the time. I don't know. So there is no shape that is returned directly. Yeah, well, I don't know. Maybe the code is changed. Change border color. Well, probably not. Yeah, I don't see where the duplication is here. No. Because here it is only concerned with drawing the next shape. So that's quite obvious. But it's really interesting. Where's the current shape drawn? Yeah, we can actually try it, right? Before asking ourselves what the heck is going on. We might as well. Is this drawing the current shape as well? Is it kind of part of this grid? So let's run it. Oh, yeah, vsync really wants to be enabled for this to work. And vsync should be available on all the platforms, but I'm saying should be because I have no idea. vsync true. Oh no, wait, vsync isn't part of the event queue. Vsync is part of the window settings. Oh, vsync is true. That's interesting. So setting the samples made it work. Wow, shit. Ooh, it does some weird buffer flipping here. That will cause epileptics to some people. Yeah, so now it's not drawing. Okay, so the current block seems to be part of this grid. Amazing. Yeah. Okay, anyway. Gee. Get grid cell. Yeah, this is cell based here. Anyway, if you wanted to basically put this into a function, I think what you could do is this. You put it into a separate scope, which is required because, you know, what I'm getting into is if you don't want to specify this type, and I would actually prefer to not specify this type, then you could use another closure. So we can say, well, let's draw something. I'm not sure if it needs to be mutable, but we will find out the hard way. And put in a closure that says, well, we take C, we take GL, and then we just put the code here, which should bind to everything it needs to actually work. So that could already work, and of course then we have to call it. And actually, I think under these circumstances, we don't have to assign it. We can just do this and get it to draw. I don't know if these parentheses are needed, but I think I've seen it. But we will try to kind of, actually I'm doing it the wrong way. I'm putting stuff without knowing if it's needed and say, well, we remove it then. But on the other hand, you know. So let's try a few things. Let's see if that even works. Nope. This function takes 2 parameters. Oh, sure. That's just a declaration, right, and not the call. So here we say C and GL. And the type of this value must be known in this context. What? 103. Just a test. So the draw state. Oh, that's interesting. So why does type inference not work here? Maybe I just pass a borrow to this, and this is already a borrow mud, so this type is not stripped or something. I think this should work. Oh, interesting. Huh. I didn't expect that. And rectangle, yeah. I actually don't know how to fix it except for putting the explicit type here. That's weird, and this doesn't change a thing. The good thing is that the borrow checker also didn't care, but probably it didn't yet run. Probably the type inference is happening first, and it failed to infer the right type of C. And I wonder why it fails to do that, because, you know, it does know the type totally, so, but not in this context for some reason. Okay, so first let's try to get rid of some parentheses and maybe even this. But I think it will have the same problem. Expected function found. Okay, so it really wants to have these outer parentheses. Okay. So now it got it. Yeah, borrow check didn't run, because if it would have told me that I can't, you know, that this stuff here is consumed and used and bound, so we cannot actually use it in the future drawing calls. So this is what the outer scope was there for. However, this seems to be a problem. So let's try to fix it, but we might not even get around. Setting these up properly. Oh, sorry. Yeah, so I think I don't want to pass, this was what you consumed here, and I don't want to consume it. So we will just pass it like this. And here we need to pass a borrow. And now GL, use of moved value GL, which is non-copyable. Oh, interesting. 103. This is also interesting. So that's a borrow much, right? And I think in order to not move it, we could specify this. And now, of course, we need to... No, wait. It's not implemented for the type. Mat OpenGL graphics. Interesting, again. And it's always this 103, actually where this thing is used. Crazy. To be honest, I don't know how to fix that. Interesting. I didn't expect that to happen. First time. See, this is what I mean. I actually don't know this stuff. Well, because this obviously, I thought maybe you have to dereference this, but this draw call, it obviously, it wants an OpenGL, right? Unclose delimiter. What? Oh. I think weird things happen. Sublime Text seems to add delimiters here. Okay. So expected... See, it inferred the type. It expected a mutable borrow of it. And this is what it got, right? A GL here is a mutable borrow. Oh, come on. Sublime. Destroy my parentheses. Yeah, I don't know what else to say here. Okay. You know what? I think this should be removed. So I don't know, actually. In theory, you could have defined these closures here and you let type inference do all the hard work. But apparently that's not as easy as I thought. It's important, though, in any case, to get the scoping right so that the closure will be destroyed and releases the variables that it bound. I think that would be one way to do it. But yeah, it didn't work. It should work, though, for just a separate function or method in case you want to define these types. Okay, that's all for now. That's all for this hack session. Thanks for watching and have a great day.